So this will just be a brief overview of validity and reliability, and then we'll delve deeper into each of the validities. So validity is basically whether or not something is accurate or true. It's the foundation of research methods. We want to make sure that everything we do in our research is valid or as valid as possible, and that's going to be a very tall order. And there's almost never a black and white answer about validity. Whether something is valid or not is kind of a continuum, and it requires critical thinking and judgment. You can't put a number on it and say it's a 9 out of 10 valid. Another important thing about validity is that validity is about a claim you're making or an inference you're making, not about the method itself. So a method could be valid for one thing and completely invalid for another, or it could be more valid for one thing than another. So it depends how you're using the method and what claims you're making or what inferences you're drawing from your use of the method. Okay, so before we get into validity, we're going to take a small detour and talk about reliability. So reliability is actually something much narrower than validity. Reliability doesn't ask, is it right or wrong, or is it accurate or not? It just asks, is it consistent? Is the thing you're measuring consistent? So another way to say this is when the true value of a thing hasn't changed, let's say my height or my weight, does my way of measuring it, my observation, stay more or less the same? So if I weigh the same thing, then my measurement of weight shouldn't change if I weigh myself over and over again. So let's say I think I have a reliable measure of weight and it's a scale, and I test it by stepping on the scale and off, looking at the reading, and doing that multiple times, maybe over a week, and in that time my true weight hasn't changed. So a reliable scale would be one that gives me the same answer over and over again. So let's say that I have such a scale and I step on and it tells me I weigh 100 kilograms. Step off, okay, tomorrow I do it again, step on, tells me I weigh 100 kilograms, step off. Maybe one day it tells me I weigh 103 kilograms, one day it tells me I weigh 99 kilograms, still pretty much in the same ballpark. So is that a reliable measure? Well, my true weight hasn't changed in that time, and the measurement basically hasn't changed much in that time. So yes, it's a pretty reliable measure. When the true value hasn't changed, the answer it gives doesn't change either. So a reliable measure is one that is consistent, assuming that the true value hasn't changed. But as you might guess, 100 kilograms is not a very accurate measurement of my weight. So it's a reliable measure of weight, but it doesn't sound like it's a valid measure of weight. I'd probably want to try it out on a few different objects and people, things that weigh different amounts. So I can see maybe it was really off for me. But it could very well be that it's a very reliable measure, but it's not a valid measure of weight. However, it might be a valid measure of weight plus some amount. So maybe it's always adding some fixed amount to whatever you put on the scale. So maybe it's adding 30 or 40 kilograms to the amount of the thing you put on the scale. So then it's a reliable measure, and it's a valid measure of the weight of the object plus another 40 kilogram object. So maybe it's a valid measure of me plus what I would weigh if I was carrying a 40 kilogram dog. So for example, there's a picture of me carrying a 40 kilogram dog. So that this just drives home the point that we have to ask, what is it being used for? It's a valid measure of one thing, it's just not a valid measure of my actual weight. Okay, but to get back to reliability. So reliability is just, is it giving a consistent answer when it should be giving a consistent answer? And it can be quantified. Unlike validity, you can put a number on reliability. It's roughly how much of the variance in the measure, how much it goes up and down, is tracking actual variance in the thing you're measuring, it going up and down. So does it go up when the thing you're measuring goes up and down when the thing you're measuring goes down, or is it moving around randomly? So an unreliable measure is one that moves up and down randomly, even when the true value that you're trying to measure hasn't changed. One way to increase reliability is to take many measurements and average them together or aggregate them. And this increases reliability because all the random error, all the random fluctuations which cause unreliability, they cancel each other out. When you take a bunch of measures with random error, sometimes it'll overestimate, sometimes underestimate. Those cancel each other out when you average across multiple measures. So by definition, unreliability is caused by random error or noise, and random error or noise can be reduced by taking multiple measures and averaging them together. So basically reliability is asking, is it picking up on a signal and not just noise? But validity asks, what is it a signal of? Am I interpreting the meaning of that signal correctly? Reliability doesn't care about that. Reliability just asks, is it being consistent? Is there a signal there? So if it's giving the wrong answer, but it's giving the wrong answer consistently, that's a reliable measure. So you can see why reliability is not an amazing achievement, right? Achieving a reliable measure that's nice, that's good. It's good to have reliability, but it's not nearly enough. It doesn't mean you have a valid measure of the thing you're interested in studying. So reliability is necessary, but not sufficient for validity. Validity is the much more challenging thing to achieve, and we're going to talk about that more now. So reliability asks, is my measure picking up on a signal and not just noise? It's a very low bar. Just, is it more than noise? Whereas validity asks, what is it a signal of? Am I interpreting the meaning of the signal correctly? Reliability is necessary, but not sufficient for validity. So reliability is easy to quantify. You can put a number on it. Validity is very hard to quantify. You can't just reduce it to a single number. And validity is a property of an inference or a claim. When I make a statement about a meaning of an observation, that's a claim that could be valid or not. But the method itself is not inherently valid or not. It really depends how it's used. So there isn't an agreed upon way to carve up validity. There are different ways to think about all the aspects of validity. And some people even argue that there's really only one kind of validity and everything is just different angles on that one validity. But I'm going to use one particular taxonomy or way to split up the different validities from Shadish, Cook, and Campbell's book. But I don't claim that this is the one true way to split up validity. It's just a very useful way. So those four validities are, first, construct validity, which basically asks, are you measuring what you say you're measuring? Internal validity, which asks, are your causal claims valid? Are the claims you're making about what causes what valid? External validity asks, are your claims about generalizability valid? The claims you're making about what this means for the real world or another population or another way of measuring it, are those claims valid? And finally, statistical validity, are your statistical conclusions valid? And we'll get more into each of these in subsequent videos. But one thing to point out right now is that construct validity applies to claims about just one variable. So it's about, are you measuring the thing you think you're measuring or you say you're measuring? And you probably have measures of multiple variables in any given study, so you can ask about the construct validity of each one. Whereas the other three validities can apply to claims about two or more variables and their association or relationship with each other. So internal validity, external validity, statistical validity can apply to claims about more than one variable.